So today we're going to be talking about solutions to equations. All right, so right now, if you can't see this right here, we're going to write, we have 6x minus 6 equals 6x plus 15. All right, that's our first equation right here. It says, which of the following equations exactly has how many solutions? One solution. So if we look at answer choice A, what do you notice is on the same side? What can I do to both sides of this equation? What's something? If I wanted to get rid of this 6x, what would I do? Take away 6x from both sides. Now look what happens when we do this. This zeroes out, but also over here, this also zeroes out. What's the only thing left we have on the left-hand side? Negative 6. What's the only thing we have left on the right-hand side? 15. Are these equal to each other? They're definitely not equal to each other. So here's a scenario. All of these variables cancel out, and we're left with two numbers that are not equal to each other. This is a scenario where we would have what's called no possible solution. So this is a scenario where there is what's called no solution. If you have an equation, there's no answer, okay? Because there's no number you could plug in to this x and this x that could make somehow a negative 6 equal to a 15. It's impossible. You can't solve it. So maybe you guys can see this visually, okay? So if you would, please go to Desmos, all right? So what I want you to do is go to Desmos, and I want you to just type in, 6x minus 6, and it graphs a line. And I want you to type in 6x plus 15. Just type in 6x plus 15. What do you notice about these two lines right there? What do we call those lines? Those are called parallel lines. And do parallel lines ever touch? No. So if you have the same x values but different constants, then they will never touch. No matter what those constants are, they will never touch. Now, there is a scenario where, what if I said 6x plus 15 equals 6x plus 15? What do you notice about these two lines? They're the exact same line. So, like, what would be the solution for the exact same line? It's an infinite number of solutions. So literally any point on that line would be a solution. So how do you know if there's only one solution? If the number in front of the x is different between the two lines, then guess what? You'll be able to see where the solution is. All right, so check this out. I have 6x plus 5 and 4x plus 15. If I zoom out, is there a place right here where you see the two lines intersect? Yeah. So what would be the answer? My answer is 5. That would be the number that you would plug in to make those equations equal to each other, right? So this is your first opportunity to kind of use Desmos. So I want to make sure you guys understand all you got to do. Now, if you want to, you could right here, you could put y equals, and you could put right here y equals, and it doesn't change the lines. Oh, I messed up there. Put an equal there and delete that. There we go. So you can still see that's where the two lines meet. All right. So right here, if we go back to our work, here we have no solution. Let's take a look at this one. Answer choice B. What does it say? 6x minus 6 equals 15x plus 15. Automatically, what I'm hoping you see that we have different numbers in front of the x, right? That's 6x. This is 15x. This is a scenario where you would have what's called one solution. So whenever these right here are different on the other side, we have what's called one. That's one solution. All right. So if we solved it, ready? Let's go ahead and solve it real quick. Here we go. Let's take away a 6x. Take away a 6x. All right. 15 minus 6 is 9, right? Take away a 15. Take away a 15. We get negative 6 minus 15. That's negative 21. And then if we divided both sides by 9, our answer for x is this improper fraction, negative 21 over 9. Okay? So we have one solution. That's the solution to this particular equation by just solving it out. Now, could you use Desmos to solve that equation? Absolutely. Check this out. I want you guys to type in 6x minus 6, and I want you to type in 15x plus 15. Let's go ahead and do that. 6x minus 6, and the other one was what? 15x plus 15. All right? 15x plus 15, and you'll see this right here. You got to find where the two lines meet. Okay, so I don't know if you guys, I'm going to zoom in a little bit here. So if you go right here, see where the two lines intersect right there at that ugly little fraction? Now check this out. If you didn't know what negative 2.3333333333 was, ready? That's negative 2.3333333333. All right. What happens? See that level right there? It gets negative 7/3. You're like, wait a second. We didn't get negative 7/3. What did we get? What did I say? Negative 21 over 9. But does a 3 go into this? Right? 3 goes into it 7 times. Does a 3 go into that? 3 times. So our simplified answer is negative 7/3. All right? So you can, obviously, I want you to see that Desmos can reduce your fraction just like your graphing calculator. But you have to type in enough 3's. So I want you to notice something this next time, okay? All right, so I said negative 2.3, and you saw a little fraction thing come up, right? But if you do a repeating decimal, you have to start doing it, and then it goes away, and then eventually it comes back so that you can change it to your fraction. All right? So this right here is a way you could check your solutions if you're solving an equation. You could check to see if you got your answer right. Type 1 into this side, type 1 into that side, see where the two lines intersect. Okay? So right now, what's the answer for the one that has one solution right here? What's our answer? Answer choice B. All right, so check this out. You guys see how this 6x right here cancels out this? So are those two numbers equal to each other right there? Is a negative 15 equal to a positive 15? No, they're not equal. So once again, answer choice C technically would be called what? No solution. Well, what do we see about here? What do you guys see about answer choice D? That says, if you can't see it, that says 6x plus 15 equals 6x plus 15. If you have the exact same line, what did I say the answer was for the exact same line? That's called infinitely many. That basically means any number works because it's the same line twice. So this answer choice right here would be infinitely many. This is a no solution. Answer choice A was no solution. And which one was only one solution? Answer choice B. Why? Because you had different variables, different coefficients in front of the x. All right, so choose B. There we go. Okay, now on this one it says solve for z. So I want you guys to write this one down. You can't really see it very well, so I'm going to write it for you. It says A times open parentheses t plus z equals 45, z plus 67. So A times open parentheses t plus z close parentheses equals 45z plus 67. And we're solving for a specific variable called z. That's what we're solving for. Okay. Step 1. I'd like you to distribute to both. A times t is A times t. A times z is A times z. equals 45, z plus 67. So the first step, I just distributed the a to the t and the a to the z. Second step, we need to get all the z's to one side of the equal sign. So here's what I'm going to do to get all the z's to one side. Did everybody see we have a z inside that term? And we have a z with this term. So we're going to move, I want to move all the z's over to the right-hand side. So how in the world am I going to get rid of an a times a z? I'm going to take away an az from this side, and I'm going to take away an az from this side. These will cancel out. Now here's the thing, you can't combine those because they're not alike. So how do I rewrite it if I can't combine them? Just write 45z minus an a times a z. That's how you rewrite this expression. So just rewrite that expression. If I put all of the variables on the right-hand side, that means I need to move all the numbers to the left-hand side. So I'm going to take away 67, going to take away 67. This zeroes out. Can I combine those? Are those like terms? No, they're not. So how would I rewrite that? A times t minus 67. All right, so there we go. Step one right there. All right, so this is the part where students sometimes struggle, okay? When we're solving for a letter, we really need to focus in on the letter that we are solving for, that variable right there, okay? Does everybody see we have a z in that term, and we have a z in that term? So those are called common factors, all right? The common factor between a 45z and an a times a z is z. So what we can do is we can actually factor out that factor out of the expression. We can factor it out. So we're going to factor out a z. If I factor out a z out of a 45z, what's the only number I have left if I factor the z out? What would you say? 45 is correct. Or put minus. Got to bring the minus down. What's left if I factor out a z out of this? What letter is left? A. Very good. Now, how can you check if you did it correctly? You check it by using the distributive property. What is z times a 45? 45z. What's a z times a negative a? Negative a z. So we did it correctly. Over here, just bring down exactly what you see, which is an a t, minus 67. So now we're down literally to the very, very, very final step, which is you always divide by what's next to the letter that you're solving for. So what is literally next to my z right here? 45 minus n a. So I'm going to, right here, I'm going to divide this side by 45 minus a. And I'm going to divide this side by 45 minus a. And this is actually going to be my final answer. I know it looks ridiculous, but we went through the problem solving process. I have a times t minus 67 all over 45 minus a. Guys, this is called solving for a specific variable. Solving for a specific variable. That's what it's called. So I'm going to type this into the Khan Academy and see if we got it right. All right, here we go. Make a little fraction. I believe we had an AT, and then I had minus 67 all over 45 minus a. Not equals, sorry. Minus a. Because it says, assume that the equation has a solution for z. All right. There we go. Now, if you mess up on yours, you can say, see a step-by-step solution, and it does go through all of it. Okay. Now here's another easy one. Okay, that one was a difficult one. Solving for a specific variable is a difficult one because you got to follow all the steps that we talked about. This one is not going to be that difficult of a problem. Okay, so all I want you guys to do is write down the equation. It says negative 25z plus 1 plus 35z equals 10z plus 1. So just write that down nice and neat. I'm going to put the equals, there's my equal sign, and then I'm going to highlight two numbers that we are allowed, two terms we're allowed to combine. These are like terms. Okay? All right, so let's add some like terms here. You can add negative 25z to a positive 35z. So if we just take those, just take 35, and you just take away 25, what are you left with? You're left with a 10. So if I put a z here and a z here, that's still 10z. So what does that give us? 10z plus 1 equals 10z plus 1. So if you have this side perfectly equal to this side, which of these answer choices is the correct answer when they're literally the exact same? What did we say that one was? One solution, no solutions, or infinitely many? Let's go back and check. Let's go back here. Here we go. All right. So here we had no solutions because they had these canceled out. Okay. Here we had no solutions because they canceled out again and they weren't equal. Here, would you guys agree these are the exact same right here? And what was our answer? Infinitely many. So we go over ours. Are these the exact same? Yes. So our answer is going to be infinitely many. So I'm just going to click infinitely many. Done. Okay. It says which of the following equations have, not has, but have infinitely many solutions. All right. So you don't have to write this down. All right. Right. I mean, you can, but I'm not making my class currently write this down. I want them to focus on the screen. Okay. Here we go. Here's our equal sign. We have a 10x and a negative 10x. Is this perfectly equal to that? Are they different? My class says they're different. You're right. They are different. If they're different, you have what's called one solution. So answer choice A is, sorry, my board is feeling my frustration. One solution. Why is it one solution? Because this 10x is totally different than this negative 10x. They're not the same. Okay? All right, how about this one? Ready? Change of colors. I've got a 10x here. I've got a negative 10x. Are those the same or are they different? They're different. These are different. How many solutions do you have? One. One solution. All right, here we go. Next one. I've got negative 10x. I've got negative 10x. Are they the same? Yes. Let's check the other numbers. Is negative 10 perfectly equal to a negative 10? Yes. Therefore, what's my answer? Infinitely many. Why? Because it's the exact same line and it touches everywhere. Okay? Last one. Here we go. Is this equal to this? Yes. But what about this? Is a negative 10 equal to a positive 10? Are those the same? No. So if the variables are the same, all right, and these will eventually cancel out, is negative 10 equal to a positive 10? No. So that means this is no solution. So what is the only answer that has infinitely many? C. C is the only answer choice that has infinitely many. Okay, here we go. We're solving for a variable. All right, it says we're solving for z. So we're going to solve for z. It's kind of hard to see, so I'm going to make it a lot bigger. It says a times z plus 17 equals negative 4z minus a b. So you're going to need to write this guy down because this takes a little bit of time and effort. So write that down nice and neat. So it says we're solving for a solution for what letter? You can't see it. It's really tiny. It says Z. So I'm going to highlight this guy. There's an a times a z. I'm going to highlight this guy. That's a negative 4 times a z. So we need to get all of our z's over to one side. So this is what I'm going to do this time, because I like to think positive, all right? I am going to add a 4z to this side, and that zeroes it out. These are called additive inverses. They always add to 0. Whatever I do to one side, I got to do to the other side. That's right. All right, here we go. Now, can we combine these? No, because that's an a times a z, and that's a 4 times a z. So I got to leave it as this. Ready? A z plus 4z. That's the expression that you have, okay? So I moved all of the variables of z over to the left-hand side, which means everything else needs to go to the other side, the right-hand side. So you got to ask yourself, how do I get rid of a positive 17? Hopefully you'll say minus 17. Whatever I do to one side, I have to do to the other side. Are these like terms? Now, I know that some people are like, that's a 6. No, that's not a 6. It's the letter what? It's the letter B. Are these like terms? No. So technically, it's negative B minus 17 more. Equal sign. Boom. Can't combine them. Not like terms. All right, here we go. Now, do you guys remember last time we did this? We factored out that z. We factored out that z. Well, we're going to do the exact same thing again. We're going to factor out a beautiful z. Now, I always write my z's with a little slash so you don't think it's a 2. That's just what I do, okay? Because I don't want to get confused with 2's and z's. I am just not a really good, when I do my 2's, I don't always do this beautiful looking 2. Sometimes I just go like this, all right? And that might look like a z to me, so I'm like, wait a second. So right there. So, oh, there we go. I put a little z. Okay, so if I factor out a z, what do I have left in this term? A, very good. Bring down the cute little plus sign. If I factor out a z here, what do I have left? 4, very good. All right, there we go. Just bring that down. So we're down to our final step, everybody, our very final step. And it's divide by whatever's next to the z. So what is here next to the z? What expression? A plus 4. So I got to divide both sides by a plus 4. Now you'll notice I used a parentheses over here, but I didn't put a parentheses over here. I'm doing the parentheses because I want you to understand that these literally cancel each other out, and my final answer is z equals negative b minus 17 all over and a plus 4. And that right there is my final answer. That's what I'm going to type in. Okay, so I'm going to go ahead and type that in right now. All right, let's see here. There we go. So we got, make a little fraction. I said it was what? Negative b minus, was it 17? All over a plus 4. All right. Woohoo! And that's how you get 100 people. All right. So this will be online. All right. I'll be uploading it so you guys can go through how to solve equations. In review, what do you got to make sure that you have? You got to know the difference between one solution, infinitely many solutions, and no solution. All right. Go ahead and try this on your own now. Good luck.